Okay, we are asked to factor this quadratic, z squared, z term constant on number 33 in the chapter 2 review. I'm going to show you this two different ways. I'm going to first show you with our area model and our diamond problem, because that's kind of how I always show you guys how to factor. And then technically this one can be solved faster, with a special pattern, but it's easier to see the special pattern at the end. Okay, so I'm going to put my z squared here. I'm going to put my 9 there. These two terms here have to add to a -6. Hey. And they're going to have the same product here, so it's basically going to be a 1, right, times the 9. So I'm going to have a 9 up here for multiplication. It has to add to a -6. So I'm looking for the numbers that will multiply together to get 9 and add to get -6, and that's going to be a -3 and a -3. And the fact that they are the same number is how I know that this is a special pattern. I end up with a -3z here and a -3z there. So as I factor these out, what I end up getting is a z and a z -3 -3. So I actually end up with the same binomial both times, right? It's, oh, I started writing x, excuse me. Z -3 times z -3. And since it's the same binomial, it's actually usually written like this: z -3 quantity squared. So that would really be my final answer, like this. Okay, now this is actually a special pattern. We can actually factor this using a special pattern if you recognize a couple things. Oh, I'll do it like this so we can actually see what the answer is. The fact that this number and this number are perfect squares is what allows us to use this special pattern. This is z squared and this is 3 squared. If you have a trinomial, a 3-piece polynomial, where the first and the last piece are perfect squares, and then the middle is double the first thing being squared, so 2 times z, times the second thing here being squared, which it is, 2 times 3 times z is 6z. This is going to fit the pattern. We have a perfect square here, a perfect square here, and the middle term is double the product of what's being squared. Now in this case it's actually a -2, but that's okay. This fits the pattern. If I see that pattern, then I know my binomial is going to consist of a z and a 3, and because this is negative, it is subtraction in the middle, and then there's 2 of them, z -3 squared. So you can get to the right answer using your area model and your diamond problem in order to factor, or if you recognize the special pattern being this, a squared minus 2ab plus b squared. And then, of course, the other iteration of the pattern is when this is plus, so it might look like this: a squared plus 2ab plus b squared. And then that would look like this: a plus b quantity squared. If this middle term is positive, then they're being added. If the middle term is negative, like it was here, then it's subtraction between them. All right, I hope that's helpful. Message me anytime.